I think it's recording. Hello. So, let me describe the problem. So basically, we have take this string right here. I'm going to simulate what this string means. Basically, the hashes represent backspaces. So let's say we have a result array where we're going to put characters from the string that have not been deleted. So we start off I at the first character. It's an F, so we push F onto the result. Then we advance I. So now we have E, which we also push onto the result. So then we push I forward. That's a hash, which means backspace. Hence we delete the E, we pop E, we move I forward again, and we see that's a hash, and so that's a backspace, so we delete the F. We move I forward, that gives us a D. We move I forward again, that gives us an A. Move I forward, that gives us a B. Then we move I forward again, that's a hash, which means backspace. So we drop the B from the result. We move I forward, that's a hash, that's a backspace. So we drop the A. Then we move I forward, that's a T. Then we're done, and we can just convert this into a string. So you could actually implement this solution in this way, basically traverse through both strings, compute the result, and then compare the strings afterward to see if they're equal. So if you were to do the same thing here, let's see if they result in the same string. So let's say I is at the first character, so we push it onto the result, move I forward, so we're going to get a B here. So then we push I forward, there's going to be a D. We push I forward, that's a backspace, so the D is removed. And we push I forward, that's a T, so we put the T here. And then we push I forward, we're done. We convert this into a string, ABT, and clearly DT and ABT are not equal, so the output's going to be false. So we traversed, we visited each character in both strings once. So you might say that the time complexity is O of n, where n is the number of characters. And for space, we use these buffers right here. So it's also linear space. So that's one way you could program this. Just use this is basically a stack right here. Or you could use what's called you can use two pointers. That's a different approach. So let me explain that approach right here. I'm going to delete what I have so far. So I'm going to show you an approach that is linear time and also constant space, like that. Let's move this here. Drop this. So the trick here is we're going to move, let me just change these pointers to be different. We're going to start from the back, and the idea is that, for example, if we can count the number of backspaces that we see. For example, here we encounter a backspace. This is a backspace. So there's two backspaces, which means these two characters will be deleted. They won't be included. So A and B are not included. So we can develop the notion of what's the next index. What's the next index of a non-deleted character? So let me just write that down. What's the next index of a non-deleted character? Character that's not deleted. So that's the question we would ask. So if we're at I, well, there's no backspaces that follow I, so we just return I. So to go to the next character that's not deleted, in this case, well, you might move I here. We see a backspace. We're going to keep track of the number of backspaces here. So initially it's 0 when I is at the end. Well, when I is here, we see there's a backspace. So we increase the number of backspaces by 1. We move I. That doesn't represent a character that's not deleted. So we move I backward again, and we encounter this. There's now 2 backspaces. So we're still looking for the index of the next character from the back that's not deleted. So we go here. We see that we have 2 unused backspaces. So we're going to use one of them right now. We're going to drop that number by 1. And we're going to skip B because we know B is not in the final string. We move I backward. We see that it's pointing to an A. However, there's 1 backspace that's not been used. So we're going to use it up right now. We're going to skip A. And so the next character that's not deleted is D. So the approach is going to be, for each string, start from the back and move to the next character that's not deleted, then compare them to see if they're the same. If they're different, then the strings are different. So by doing this, we actually don't use extra space. So let me illustrate that here. So let me just see if I can write that down. So go to the next character that's not deleted. So we're going to do that in a loop. Go to the next character that's not deleted. Next. So in both strings, in both strings. If they're the same, keep going. If they're not the same, then we know to return false. Otherwise, keep looping. And so let's do it here. So here we start I off at the end of S, and we start J off at the end of S. Then we invoke sort of our method. Let's call this method next character or something like that. That's what we're going to call the function. So there's no backspaces that are unused, and so the next character that's not deleted is T. The same is true here in this string. And so when we compare them, T is equal to T. Again, we're not using extra space other than the pointers, so we do not return false. It's looking good so far. Next, we move I to the next character that's not deleted. So we did that already. So I is here. That's a backspace. We keep going because we haven't found our character yet. That's a backspace. We keep going. We have unused backspaces here, so we skip that. We keep going. So that's an A. We have an unused backspace. So we're going to use it. Then we get to D, and we see that there's no backspaces that are unused, and hence this is the next character that is not deleted. So we sort of do the same here. So we move J here, and the number of backspaces is going to be it's going to go from 0 to 1. We're going to go here. That's a D. However, there's an unused backspace, so we're going to delete this. And this is going to be skipped, so we keep going. And so the next character in T that's not deleted is going to be B. So we compare B and D, we see that they're different, hence the output's going to be false. So that's sort of the gist of the algorithm. So basically, if you're able to exhaust both strings in this manner without encountering a pair of mismatched characters, then we return true. They are indeed the same character. And again, the time complexity is linear time, and the space is O of 1. So I won't write the code here. I think I'll let you guys figure it out. But if you need code help, I can provide that as well. But this is the basic idea. Let me see if I can stop this recording.